The direction of the conventional current flow in the wire loop can be determined by using a rule known as Fleming's right-hand rule. As the name implies, this rule involves the use of your right hand. To use the rule, you hold your right hand with your thumb, first finger and second finger extended, as shown on the screen. Align your first finger with the magnetic field from the North Pole to the South Pole. Point your thumb in the direction of rotation of the loop. Your second finger will now be pointing in the direction of conventional current flow. In the example shown here, as you can see, the first finger is aligned with the field, and the thumb is pointing upward in the direction of rotation of the red half of the loop. The second finger is pointing out of the screen, indicating that the conventional current is flowing out of the red half of the loop. We will now take a look at our generator, as the armature rotates through 360 degrees, to see what sort of voltage is produced. The angle between the direction of movement of the armature loop and the flux lines of the magnetic field is known as the phase angle. In the position shown here, the armature loop will initially be moving in parallel with the magnetic field, with a phase angle of 0 degrees, so no EMF will be induced. As the armature begins to rotate, the loop begins cutting the field at a small but increasing angle, and an EMF begins to be induced. As the armature loop approaches 90 degrees to the direction of the magnetic field, the maximum number of lines of flux are being intersected, and the EMF is at its maximum. Between 90 and 180 degrees, the number of lines of flux being cut by the armature loop reduces again, so the EMF reduces. At the 180 degree point, the loop is again moving in parallel with the magnetic field, so no EMF is being induced. As the armature loop moves around from the 180 degree point, it once again begins cutting through the field lines, but now in the opposite direction. So an increasing EMF is induced in the opposite or negative direction, until at the 270 degree point, the loop is cutting through the maximum number of flux lines, and the negative EMF is at a maximum. The EMF now begins to fall again until the circle is completed. The armature loop is again moving parallel to the field. The EMF is 0, and the cycle begins again. Mathematically, the induced EMF is directly proportional to the sine of the angle between the direction of movement of the armature loop and the magnetic field. The alternating voltage produced by this type of generator is known therefore as a sine wave output. The current flowing in the external circuit will be an alternating current, or AC. That is to say, the current will first flow one way, then change direction and flow the opposite way as the direction of the induced EMF changes.